Okay, now welcome guys. We have established in our previous video that chemistry has to do with the study of matter, and we say matter is composed of atoms. So today we want to dive deep into the concept of atom. By the end of today we should be able to know at least a very good extent concerning the concept of atom. Now, as we all know, as people keep growing in age, they form theory about different things. Some people will tell you that the earth is spherical. Some people say the earth is flat. So when the term atom came to science diction, people tried to figure out what does it really look like. There is a lot of theory about atom as to how atom look like. People like John Dalton came with their own. From John Dalton we have J.J. Thomson came with his atomic theory. From J.J. Thomson, Ernest Rutherford brought his own. From Ernest Rutherford, Niels Bohr brought his own. From Ernest Rutherford, de Broglie brought his own. From de Broglie, the current one we are using now is Schrödinger, which is an advanced one. But today the basic one, which is mostly taught now and is widely used, is the combination of the Ernest Rutherford concept and the John Rutherford concept of atom. So what do they say concerning atom? Now, Ernest Rutherford, after his experiment, draw a conclusion. He said that, and they name it the John Rutherford planetary atomic model. Now, he viewed an atom like this. He said an atom is like the solar system that we have, where there is a body in the center, the way sun is in the center of the solar system, and other body revolving around it, like the way other planets are revolving around the sun. That is how he view atom. That's what he said an atom is. He said that the center, the core that is like the sun in an atom, is called the nucleus, and those ones that are revolving around it is called the electron. That's what Ernest Rutherford brought. He said that the one revolving around it is the electron, and it is negatively charged. And then the one at the center, which is like the sun at the center, is called nucleus, and it contains two things, which is called the proton and the neutron. He also said that the neutron has no charge, so it's neutral, it doesn't have any charge at all, but the proton is positively charged. Now, we have different atoms, different with different size and different charges. So today we are going to look at how to draw an atom. Basically all atoms have this electron and the sun. So let's see how the rest will look like. Thank you. Now let's go with the structure of the atom. Now we see that it's like the planetary model. This is our nucleus. Let's call this our nucleus. Then these are the orbit. Every atom contains basically this. Any atom at all contains this. Now this is what? The nucleus. And then the part they follow is the orbit, the way you have orbit of the earth and the rest. Now this one is negatively charged and this one is positively charged. This one contains proton and the neutron. The proton and contain neutron and proton. Now let's see how we can draw the structure now. The first element we have on the periodic table is hydrogen. Hydrogen has just one electron. So we draw a normal circle, any size you want. It doesn't necessarily matter the size. Then you draw a circle around it, then you put one electron. This is the structure of hydrogen. Now the next atom we have is the helium. Helium has 2 electrons. The number coming is telling you the what? The number of electrons it has is called the atomic number. Like it corresponds to the atomic number. It will give you the number of electrons you put there. Now the next, you draw your orbit. This is our nucleus. You put two electrons. Now the next element we have is the lithium. Now you draw your nucleus. Then the question is, should we put another electron here? Of course no. There is a theory. The theory says the maximum number of an electron that each of these orbits can carry is denoted by this formula 2n squared, where the n represents the what? The number of orbits. If you have this orbit, the first orbit is 1, the second orbit is 2, the third orbit is 3. So if you want to determine the number of electrons that can enter the first orbit, now you have 2 times 1 raised to power 2, which is giving you what? 1 raised to power 2 is 1 times 2 is 2, which is giving you what? 2 electrons. So you cannot put more than 2 in the first orbit. So when you reach the maximum for any orbit, leave that orbit, then draw your next orbit. Now, so for the second orbit, you have 2 times 2 raised to power 2, and it's giving you 2 raised to power 2 is 4 times 2 is giving you 8. When you get to the next orbit, that's the third orbit, 2 times 3 raised to power 2. 3 raised to power 2 is 9 times 2 is what? 18. You understand? And you follow it in that order. Then, having know this, there's something they call the octet rule. You need these 2 laws, this formula first, and this octet rule. For you to draw any orbit at all, any atom at all, you need these 2 things. These are the most important things. Number 1, these 2 n raised to power 2 and the octet rule. What is the octet rule all about? This is not a common rule, but it's very necessary. Now, the octet rule states that the last orbit, like the outer orbit, must not be more than 8. So when you are drawing, if it reaches 8, just stop there and move to the next orbit. Don't allow it go beyond that. The last orbit must not be more than 8. You get? So let's go to the next one. Since this one is up to 2 now, we move to the next one. So we have our what? 1 electron here. The next atom we have is what? The beryllium. Is the beryllium. Now, beryllium has 4 electrons. You draw your this. Two electrons. You have drawn your beryllium. Now we will not continue to draw it this way, but when we will move to other higher atom, how do we draw other ones with higher number of electrons? Drawing that alone will help us to understand the rest of the theory. Now let's pick 2 atoms. Now 2 very important atoms. Now we will put atomic number, let's pick 19 and 20. It will clear the rest of the theory. Now number 19 is potassium. Potassium has 19 electrons. How do we draw it? Like we said, first of all, you draw your nucleus, you draw the first share. Now 2 as enter, remembering your 2 times what? N square. 2 as enter, we say the first share contain maximum of 2. The next one, 1, 2, 3, 4, 5, 6, 7, 8. That's reached 8. Stop. Move to the next one. Remember your 2 times 2 raised to power 2 for the second share, giving us what? 8. Now we move to the next share. So remember, we have put 2 here plus this 8 outside. So we have already what? Used what? We have used 10 out of it. We are left with what? 9. Do you understand? We put 1, 2, 3, 4, 5, 6, 7, 8. 8 from this 9. We are left with what? 1 electron. Remember your octet rule. Do you understand? Normally, let me explain this now. You know, normally if you calculate for your 2 times 3 raised to power 2, you are going to get 18. You get. So it means this third share now can contain up to 18. But according to octet rule, if you put this 9, if you put this one now, you are getting 9 electrons, and this is the what? The last, and that will become the last share you get. So you cannot put the 1 here. Octet rule say the last share, if that share becomes the last share, then this rule of 2n square will be overruled. We will not use it. You understand? We cannot get 9 in the outermost share, so we have to introduce another one. You understand? So remembering this rule, let's draw. If you draw this thing, calcium, the difference between calcium and potassium, if you are drawing calcium, which is atomic number 20 now, it's not hard. It's just to put 1 now, you get your what? 20 to 90. So that's it. So the first thing to note here is that what? All atoms are made up of what? The nucleus, which is a combination of the proton and the neutron. Then an electron revolving around it in an elliptical orbit. You get. The rule for filling the rule for drawing it is 2n squared. That is n for the number of orbits, and then the octet rule, which says that the last share must not contain more than 8 electrons. You get. Let me clear something again. Let me clear some terms again. The last share is called the valence share. That's the special name for the last share. Then the last electron is called the valence electron. So with this theory, you can be able to draw any atom at all. Just follow this rule. You can, using this share principle, you can be able to draw the structure of any atom at all. An atom is one of the most important, is the most important thing in chemistry, so you must have to draw it. You just have to draw it. Learn it, because it has a lot of message to pass to you. In our subsequent video, we will talk more about that. Like if you look at something, it has a lot of information that we'll be talking about later. Now something like hydrogen, now having 1 electron in the outermost share now is telling you that it belongs to group 1. Now having 1 share is telling you that it belongs to period 1. You understand? So we talk about all of that. Now if you look at look at this cation that we just draw now. It has a lot of message, so you have to go and learn. You have to pay attention to this, practice it very well and understand. Now if you count it, this is 1, 2, 3, 4. It has what? 4 shares. It's telling you it belongs to period 4. The number of orbits tells you the period an atom belongs to. It belongs to what? Group 4. It has 1 what? Electron in the outermost share is telling you that what? It belongs to what? Period 1. So we talk more about that in our subsequent video. Please subscribe, share and like, and if there is any other concept you want me to discuss, please let me know. Thank you.